Um, Welcome to the webinar, the Queensland webinar on barriers. Today we're going to cover a number of items. We're going to do a quick overview of what a barrier is. We're going to discuss some of the compliance requirements. We're then going to look at the loading requirements. We'll talk about the standards and NCC changes. We will discuss the various compliant pathways for barriers. We'll also discuss briefly why compliance matters. Discuss about AGWA's assistance in this space and more generally what AGWA provides as assistance for all members. And then we'll discuss a number of submitted questions, and depending on time availability, we'll open up the floor and do a Q&A. So let's start. So what are they? Well, a barrier can be on a set of stairs, it can be in an internal landing of a residential building, it can be the external balcony of a residential building. Similarly, it can be balconies within high-rise developments. It can also be used in commercial applications, such as shopping centres and other such places where there's a lot of people. And it also can be a pool fence. And in some very specific circumstances, it can be both a pool barrier and a fall prevention barrier. In this particular case, specifically where the height is less than 1.8 metres, it needs to comply with the requirements of 1926 and Section 7 of 1288. So what is the difference? Well, fundamentally, it's not a one-size-fits-all solution. It's primarily about imposed loading, and that can be specific to the barrier type, to the building location and height, so wind loads, and also the occupancy type. So where is it? Is it subject to overcrowding and some other factors? But it fundamentally relates to the overall strength that the system needs to resist as a result of both human interaction and where applicable wind loads. I'm just going to discuss wind loads very briefly. Wind loads are a little bit outside the scope of this webinar, but in some circumstances, and probably more so in Queensland and some of the other states, quite quickly they can become the governing load, particularly, for example, if the building is very high up and exposed to a lot of wind. So it is a little bit more difficult to discuss wind loads, so we won't be touching on it in a lot of detail today. Primarily around the guidance given in 1170.2 requires you to consider it as a freestanding wall, and using that guidance can sometimes lead to wind loads that seem quite extreme and potential for over-design of the system. In an example AGWA done, we conducted a wind study where the sliding door that was behind the barrier, we calculated the wind load to that, and then obviously did the wind load for the barrier, and it was 150% greater than what was required for sliding door. So it is quite a complex area, and we won't be touching on it a lot, but in some cases it can be the governing load and be the primary design criteria you would need to look at for the barrier. Talk about common construction types. So primarily barriers can be broken down to two distinct types. That is an infill barrier. So that's where the glass does not support any of the handrail loads, and they are transmitted through posts and a handrail that's connected to them. The other most common type is a structural barrier. So this can be a barrier that does have an interlinking handrail or has no handrail or no load supporting handrail. And in this case, all of the loads are transferred through the glass into the fixings. We talk quickly about infill glass barriers. So this is covered in clause 7.4.7 of 1288. There is about four primary types, two are about the same. So there is four-edge supported, where the glass is engaged on all edges. There is two-edge support, where it's only either the both top and bottom edge or either side. And there's also mechanical fixing conditions where the glass can be clamped into place. Obviously, in these instances, the span is the shortest distance between the supports, or the shortest distance in the case of four-edge supported installations. With glass barriers with an interlinking handrail, these can be many support conditions. They could be spigots, they could be offset handrails. They can also be face fixed, or they can be fully and continuously supported. Additionally, they can also be some proprietary clamping channel systems, but we'll talk about some specifics about those a little bit later. And then we have structural glass barriers that have no handrail or a non-load supporting handrail. Now, you're going to hear me comment about this diagram below quite a bit. So the diagram down below nominates what we see sometimes as what people are calling an interlinking handrail, but it's clearly not. This is your capping rail that's generally made out of 15 by 15 stainless steel channel, usually about 1.5 wall thickness. This is not an interlinking handrail. This is a non-load supporting handrail and is primarily for decorative purposes or for protection of the laminate in some cases. There is a lot of misconception in the market around what exactly is an interlinking handrail, but we will discuss this in more detail when we talk about the loading requirements relating to barriers. Let's talk about some compliance requirements. So primarily, where does all these requirements come from? They originate in the National Construction Code, and the volume that they come from depends on the class of building. For class 2 to 9 buildings, that's volume 1, and for class 1 and 10, that's volume 2. So within the National Construction Code, it references a number of standards, and the ones that are relevant to the discussion today are 1170.1, which is imposed live loads, 1170.2, which is wind actions, 1288, which is for glass selection, and in the case of pool fencing, it's 1926.1. We're going to talk about some of the loading requirements and where these come from and how they apply. We are going to talk primarily using Table J1 from Appendix J of 1288. This is essentially the same information that can be found in Table 3.3 of 1170.1 with just a little bit more detail. Now, there's a lot of data there, but let's have a look at some specifics. So the primary thing we will be looking at is the occupancy type. So this is the occupancy type that relates to the loads that the barrier will have to resist. In this case, I've highlighted occupancy type A, which that relates to all areas internally exclusively one dwelling. So the first slide I showed where it was internal landings or stairways. So that's loading class A. And you can see that with every occupancy type, there are 5 primary loads there. We're going to discuss these in more detail, but we're going to highlight one particular load, and that is the horizontal uniformly distributed line load. So this is a kilonewton force per metre that is applied to barriers. And in the case of class A, that's 0.35 kilonewtons per metre. We then deviate and look a little bit further down, we can see C5. So C5 is the occupancy type to areas subject to overcrowding. Now that could be within a shopping centre and other such areas where a lot of people can congregate. And obviously that means the barrier must be designed to have the capability to resist a much larger load. And in this case, you can see that uniformly distributed horizontal line load has now gone from 0.35 up to 3 kilonewtons per metre. That is almost a 9 times greater load. So it very much is not a one size fits all. It's very specific on the barrier type and its location. We're going to discuss the 5 loads now in a little bit more detail, and we'll start off with the uniformly distributed line load. Now, in this case, we're discussing the C3 occupancy type. It is by far the most common type that most people will encounter, because that will cover you for external individual balconies and all internal elements, because it being higher stringency than Class A, it obviously can be used there. The only thing this doesn't cover is obviously C5, and that's where the very extreme case in areas subject to overcrowding. So in the case of the uniformly distributed line load, the horizontal component, it is equivalent to about 76.5 kilograms per metre that is applied to the top edge or the handrail of the barrier. Now in this case, that's horizontal, so it's into the screen. And that is mimicking people leaning up against or over a barrier. That's what that's trying to represent. We look at the next load. In the case of C3, the vertical uniformly distributed line load is identical. It does vary in some of the occupancy types, but in this case it is the same. And this is again about 76.5 kilograms applied downward to the barrier system. So that's people leaning over the barrier that could be applying a force. We move to the third load that applies to the top edge of the handrail. This is a concentrated load, so it's applied over a 50 millimetre diameter, and that 0.6 kilonewtons is very specific to every occupancy type. So regardless of the occupancy type, all of them have the 0.6 kilonewton concentrated load. And again, this is representing someone potentially placing their hand against the handrail. It is applied inwards, outwards, or downwards, depending on the worst case. And this 0.6 kilonewtons is approximately 61 kilos. So this will become important when we speak about interlinking handrails shortly. Again, this load can be applied downwards. Then we move into the loads that are under the heading infill. Now, I just need to point out there is a little bit of confusion when it comes to infill. The infill barrier and infill loads are 2 distinct meanings of the word. So an infill load is still applied to a barrier that's not an infill barrier. So in this particular case, with a point-supported cantilever system, infill loads are still applicable. And in the case of C3, there are 2 types. There is a uniformly distributed load, which in this case is 1 kPa. So that's a pressure applied over the surface of the barrier. And there's also an additional concentrated load. Now, in the case of this particular setup used in this example, that load application would be mid-span on the end of the panel, because that is the most vulnerable position for that infill load. In some cases, the concentrated top edge or handrail load and the any direction infill concentrated load can be in the same spot. So in some cases for structural barriers that do not have a handrail, these can be in the same spot. So that's covered the loading. We'll use that a little bit later as we discuss some of the compliance pathways. But let's talk specifically about the recent changes made in 1288 and also some pending changes that we hope will be published very shortly in regard to 1926, which is the pool fencing standard. We'll also discuss a very specific change that was made in NCC 22 relating to barriers. Let's talk about the changes, the major changes within 2021. Primarily the change in the 2021 version of 1288 only added about 3 or 4 additional items. It basically spent a lot of time clarifying what has always been the case, and that is there is no direct table guidance given for point fixed barrier systems. It has always been the case, but now this has been made much more apparent with the current wording of 1288. And additionally, with 1288, there's been a few changes that should make compliance a little bit less stringent in terms of always having to either use a limited set of tables provided or having to go straight to a performance solution. But let's talk about the specific changes. So first and foremost, monolithic toughened products are not permissible in any barrier type when they're protecting a height greater than 5 metres. I will answer a very specific question around that 5 metre rule a little bit later, but basically saying as soon as you go to a height, difference in height, protecting a difference in height greater than 5 metres, monolithic products cannot be used. A good way to remember this is, unless it is a contractually specific requirement for heat soaking, this means now there should never be a scenario where a barrier is required under 1288, specifically clause 3.8.2 in class 2 to 9 buildings, where the glass must be heat soaked for a barrier, because you are not permitted to use a monolithic product greater than 5 metres, and at 5 metres is where heat soaking in certain building classes kicks in. So that should trigger you to say that maybe there's some more digging need to be done here as what glass should be selected. Again, only if it's a contract specific requirement where all glass in the building must be heat soaked, then you would have instances where barrier glass could be heat soaked. There are some specific changes based on barrier type, which we will go through a little bit further on. And importantly, in 2 of the last major changes, there is now a requirement for structural barriers that do not have a handrail or a load supporting handrail. They must now meet an additional performance characteristic, and that is a post-breakage requirement. I will talk about post-breakage in a few later slides. One of the major changes to the 2021 version, and one of the most positives, is the adoption of 2 new appendix methods. So appendixes. So Appendix H is a test methodology for barrier systems, and Appendix I is a method to demonstrate post-breakage behaviour. Appendix H is an excellent addition, as now it bridges the gap between the limited table guidance given in Section 7 and going all the way to a full performance solution. So Appendix H is a test methodology that is a normative reference within 1288, and due to that, it's able to be used as a DTS compliance pathway as per the provisions of the NCC. We will talk about Appendix H and Appendix I in more detail as we get further along in the presentation. Talk about 1926.1. Now, this is yet to be published. It is currently gone to vote, and if it is supported, it should be published in the near term. There are 2 major changes relating to glass barriers that actually clears up a DTS compliance issue. So there's an expanded clause, which is 2.33, relating to glass barriers. But very importantly, there is now the addition of a test methodology that's going to be nominated as Appendix G. This provides now a DTS pathway that potentially does not exist as currently published. If you look at 1926, the previous version, 2012 version, it says for glass barriers, refer to 1288. If you refer to 1288, it directs you to clause 7.5, which says for glass pool barriers, refer to 1926. So essentially you go around in circles without a clear DTS pathway. Now, the only 2 possible ways is you design the pool fence as a full barrier, which generally leads to over-design, or you are limited to using a test appendix that's in 1926 that you shouldn't be using. So that is Appendix C. Appendix C is a test methodology for barriers, but it specifically says in bold black writing at the top, not to be used for glass barriers. So under those provisions, there really is no straight DTS pathway. So to remove that issue, there's been the adoption of an appendix, and I'll talk about this appendix a little bit further on, but it essentially is a combination of the existing Appendix C and some of the items taken from Appendix H in 1288. I'm going to talk to a specific change within the NCC, and that is in relation to face-to-fix barriers. So previously to the adoption of NCC 2022, there was no specific guidance given for what gap must exist between the edge of a barrier and the inside face, the edge of a slab and the inside face of a barrier. Historically, what had generally been applied was the vertical gap requirement, which was 125 mil, but that in some cases is not appropriate for a horizontal distance, as that is quite a gap, and items can potentially fall down. AGWA was involved in a barrier inspection not too long ago where there was a significant gap between the edge of the balcony and the inside face of the barrier. It was over 125 mils in some instances. And in part of the investigation, as we were interviewing some of the apartment owners, one story was that a homeowner had found a deceased rabbit on their balcony, and it took them about 3 days to figure out that it come from about 3 or 4 levels above, and the unfortunate bunny had fallen down the gap. Now, it just happened to be that during that inspection, the NCC was already looking to address this. So it was published that now there is a restriction to a 40 mil gap. Now, it is both nominated in the housing provisions and in volume 1 of the NCC for class 2 to 9. We're going to discuss the compliance pathways for barriers. Now, we're going to specifically focus on barriers greater than a metre because that is where the requirement kicks in for the NCC. AS 1288 does provide guidance for barriers at protecting height under a metre, but we're not going to address them today. We're going to specifically focus to barrier design for protecting height greater than a metre. So there are 3 principal pathways that can be used. There are the tables that are provided within AS 1288. There is a compliance pathway through the Appendix H, and where required guidance from Appendix I. And then there is the conventional engineered performance solution that involves engagement of a suitably qualified individual. Now, depending on the state, that can have different meanings, which generally means an engineer that can do the full design for the barrier. We're going to talk about the tables first, and then we'll move through the other ones. So in AS 1288, there are 3 selection tables provided, 7.1, 7.2, and 7.3. We look at 7.1. It's applicable to cantilevered barriers with an interlinking handrail. Now, there are some diagrams provided in there, but we have to be a little bit cautious when we use table 7.1 because it provides guidance for glass selection only. So it is only applicable when the glass barrier is fully and rigidly fixed for the full length. So that means essentially it's a grouted channel. All point fixings do not conform to this, so 7.1 cannot be used. And some proprietary channel systems that rely on clamping, that generally relies on discontinuous clamping, so that wouldn't conform to the requirement to be fully and rigidly fixed for the full length. So really this is only applicable to essentially a grouted channel and some other specific installation methodologies. But the issue that we have, and it's primarily because 1288 is a glass standard, is it does not provide conformance for the interlinking handrail. It must separately demonstrate compliance to support the serviceability limit state. So that's nominated in 7.45B, where there must be supporting evidence. So this guidance on 3 panels that are 1 metre wide, that you don't need a termination, or if there's 3 panels and it's under 1 metre wide, then the handrail must terminate, and so on. That really is only applicable and relevant for glass selection. So there is always the requirement to independently verify the handrail performance. Now, I will speak about that in a couple of slides and show you also why some of the handrail types that are used don't satisfy the criteria for interlinking handrails. Table 7.2 is provided for 2 and 3 edge supported barriers with an interlinking handrail. Now, this is not a very common barrier type. In fact, I couldn't quickly find a photo to illustrate it, as I would believe in most instances, if you did have a set of posts there and rails, you would most likely connect the handrail directly to the posts and then turn this into an infill balustrade, although there is the ability to do it as an interlinking handrail. Now, again, the guidance given within the tables is only for glass selection, and you still must independently demonstrate compliance that the handrail, in the event that there is a panel failure, and that includes an end panel, that the remaining handrail can support the loads. So let's talk specifically about that. So if we have a look here, as the standard is written, the handrail, in the event of a panel failure, like I mentioned, either a mid-span panel or an N-span panel must survive these loads that are nominated here. Now, in the case of the diagram down to the right, we can see why this type of handrail or capping rail is going to struggle, whereas some other types, and in terms of ones that still apply to the top edge of the glass that are double walled, they may have the ability to survive some of the loads. And the reason being is the requirement is essentially because of this. If we look at one of the loads that's for the top edge of the handrail, we're picking the 0.6 kilonewton concentrator load, which I mentioned is consistent across all occupancy types. It means that this handrail must survive in a mid-span configuration 61 kilograms of force downward over a 50 mil diameter, and in the case of a non-terminated end span, in a cantilevered fashion. So if we go back to the previous slide, you can see why those 15 by 15 capping rails, there's no way that they have sufficient rigidity to survive those loads. So they are a non-supporting handrail, and that would result, if they are used, that the barrier should be designed as a structural barrier with no handrail. Here's some examples of interlinking handrails that are probably a lot more substantial and would most likely survive for the load nominations. Now, obviously, it would be dependent on the spans. If we go back here, depending on how big the gap is between the panels or how big the end panel is, that obviously would affect the performance of the handrail significantly. In some of these cases, these would survive various loads. We're going to talk about infill barrier and the table, which is table 7.3. This is probably the most useful table within AS 1288, and very specifically for replacement or repairs or already installed scenarios. Again, the guidance that is given in this table is for glass selection only. So in this case, the handrail and the post must demonstrate independent compliance for the relevant loads as per the occupancy type. Going to look at table 7.3 in a little bit more detail. As you can see, there are a number of nominations of design loads there. There are 3 uniformly distributed loads, and there are 3 concentrated loads. And again, these come from the infill component of the imposed load table. And again, we're going to use C3 as the example. So in the case of C3, the infill design loads are a 1 kPa uniformly distributed load or a 0.5 kilonewton concentrated load. So what we do is if we go back to table 7.3, we highlight both of those. So you must look at both of them at the same time. And for example, in this case, we say that we're looking to use 8mm monolithic toughened glass. So we should know by definition that means this barrier is protecting height less than 5 meters. If we look at 8mm, we can see that the 1 kPa uniformly distributed load for 8 millimeters is 1300 millimeters. Now, in the case of the example here, that is the width of the glass because that is the distance between the supports. So it's 1300 for the 1 kPa load. Then we go and have a look at what we can get out of the 0.5 kilonewton concentrated load, and we looked that it's 1860. So in this case, the maximum span that could be achieved with an 8mm monolithic toughened glass in this configuration would be governed by the 1 kPa load, and that is 1.65 meters. Now, these loads, the governing load will vary between the uniformly distributed load and the concentrated load, depending on the glass type and its thickness. That is why you must look at both of them together. And in some other instances, if we look at actually I've highlighted 10mm there, so I've probably spoken about some different ones, but we'll correct that mistake. If you have a look to the one beside it, which is the 8mm, you can actually see that the governing span reverts down to the 0.5. If we now talk about structural glass barriers, so this is with no handrail or no load supporting handrail. And again, I'll show the capping rail, which is most certainly a non-load supporting handrail. There has been some changes in the requirements. First of all, there never has been, and there currently is not. There is under no support condition can glass be selected using AS 1288 tables. So there is no guidance given within the tables for structural barriers with no handrail or no load supporting handrail. These all must be tested to Appendix H that we will speak about, or a conventional performance solution is required. In this particular barrier type, protecting any height, monolithic glass cannot be used. And another important feature around the design criteria for these types of barriers, which sometimes can be missed because the paragraph is after a number of diagrams within the standard, is the requirement is for the SLS loads, so the serviceability limit state loads, and to be applied in the event that there's one layer broken. Obviously, because we cannot use monolithic glass, that infers we're using a laminated product. So that means one of the lights of the laminate must be broken, and then the SLS loads applied to that semi-failed state. Additionally, which is another new requirement, is the barrier shall demonstrate some what is referred to as post-breakage behaviour. And this is where all layers are broken, all glass layers are broken. Now, this glass could be a heat-strengthened laminate or a toughened laminate. So in either case, all the layers are broken, and then a 200 Newton concentrated load is applied to the worst area. And this must result in a deflection of less than 250 millimetres. Now, I do note in Appendix I there is no load duration given for that case, but it would be reasonable to assume the guidance from Appendix H could be used, which I believe is 10 minutes. Although it potentially is considered this load is not a medium-term load and would be a short-term load, which would move it down to 3 seconds. But currently it's not specified, but there will be some amendments made to cover that off. But essentially what this post-breakage requirement load means is conventional laminates just do not have sufficient stiffness in their interlayer to work. So when we're talking about structural glass barriers that do not have a handrail or contain a non-load supporting handrail, we're very specifically speaking of high-performing interlayers. There are a couple of brand names out there. They're generally very thick and they're very stiff, so that they do have the redundant capacity that in the event all the glass is broken, they are stiff enough to resist that load being applied to them. Going to talk about the new test methods that have been applied to AS1288. So the first one is Appendix H. So this is a normative reference. And this demonstrates NCC DDS compliance because AS1288 is a primary reference document within the NCC, and the appendix is a component of that. So if Appendix H is followed in full, then this is a suitable DTS compliance pathway for barrier design. It tests the barrier as a system, so that includes the fixings and the handrails where used. Historically, there were cases where the glass was being designed and you could have a lovely engineered piece of glass, but then they could be put into substandard fixings, be they spigots, standoffs, or other such ones, where they just are not designed to carry the load. So to address this and be more specific to a barrier as a system, the Appendix H was developed. This will be primarily undertaken by hardware suppliers. The reason being, if it's done on a site-by-site basis or case-by-case, you're probably looking at almost identical costs to what an engineering performance solution would be. So there's not real benefit. Whereas a hardware supplier, they can take their fittings that they use for their glass and a handrail, if they have setups that incorporate one, they can have that tested as a system, and then they were able to sell that over and over again with the supporting Appendix H document to demonstrate its compliance under the loads. So this is that you should be starting to see Appendix H test out in the market. It's still relatively new and the industry is still getting their head around how this best works. I'll speak about some work that AGWA is doing in this space shortly. But this is a great change and should allow for good design. Now, specifically, what is the appendix test? It is a way of testing the setup. In this case, in this photo, it's a spigot supported a barrier system with potentially an interlinking handrail. Now, because it is a DTS pathway, all loads must be applied, regardless of if they govern, whereas in some instances with a performance solution, the engineer may know which load would govern and that's all they would show the testing to. But in this case, because the ability of this, it can be used not by an engineer, so it doesn't require interpretation by a suitably qualified individual, all loads must be applied in every case, regardless of if they govern. Now, I will highlight that for structural barriers with no handrail or no load supporting handrail, when you are applying these loads, so these imposed load tables are SLS loads. I'll talk about how we move these into ULS in a little bit. But for structural barriers, if you're testing one that has no handrail or no load supporting handrail, then one layer of the laminate must be broken when the SLS load is applied. We have a look at ULS loads. So generally, in most cases, the ULS load, the glass in this particular scenario it's a 1.5 of the SLS load. But there are some additional requirements when we're talking about prototype testing, which is what Appendix H essentially is. So normally you would apply your SLS load times it by 1.5, but there is the requirement to consider a coefficient of variation. So it's a mandatory requirement. It's a shell within Appendix H, and it nominates in the case of monolithic toughened glass a coefficient of variation of 10%. So what we do is we then move to the table that's provided in 1170.0, and we have a look at table B1. and we can see that there is a resultant KT factor. Now, the KT factor depends on the number of samples that are tested. So in the case of only doing one sample setup, then that would be a sample size of 1, and the relevant KT factor for a 10% coefficient of variation is 1.46. So in this case, we would take our SLS load, we'd multiply it by the 1.5 to bring it up to the ULS, and then we'd times it by an additional 1.46 to account for the coefficient of variation requirement. Now, the reason this is in place is sample or prototype testing sometimes is not fully representative of what would be out in the field, because you could be lucky and test an inherently very strong version, or they could be weak. There is some variance within the strength of the system, so that is incorporated by increasing the load during this Appendix H test to account for any possible variation. Now, if you didn't want to apply the 1.46 to your sample, because that is quite a significant load, you can increase the number of samples. If you look at the bottom of that chart, if we increase that to 10 samples within the Appendix H test and we did 10 separate instances, we could drop the KT factor down to 1.21. I will note that some Appendix H test reports have had interesting guidance around this. Some have not included it, or some have simply applied 10% to the ULS factor, where that 10% is the coefficient of variation. It is not the KT factor. So you do need to look at some guidance from Table B1 of 1170.0. We talk about Appendix I. So Appendix I is a pathway that can be used to demonstrate post-breakage behaviour for barriers that have no handrail or no load supporting handrail. So fundamentally for this test, it requires all layers of the glass are broken, and then a concentrated load is applied. Now in this case, there are some side clamps to that panel. So the most vulnerable spot is the centre span at the top, and it is a 200 Newton load applied. And again, the total deflection of that system must be less than 250 mil. So this is in relation to if in an event that all layers of the glass are broken, that the barrier does have some form of redundant capacity. It's obviously not to the levels of stringency that would be required if it was serviceable, because clearly if both layers are broken, this barrier is not in a serviceable condition, but it still does provide some restraint. I will also mention that the testing should be representative of the intended temperature application. So in some cases where barriers are exposed to very high temperatures, that can affect the performance of the interlayer. So it may be appropriate that the Appendix I test is done at a temperature representative of the installation. I move over to pool barriers. As I mentioned, there's a new appendix coming out, hopefully not too far away, for pool barriers. And it will be a test method. Again, it's essentially like Appendix H, but it is nowhere near as stringent for various reasons. We are not primarily protecting a fall here. The main intent of the pool barrier is to restrict access from young children. It will remove, as I mentioned, the issue of no real straight DTS pathway with pool fencing. And essentially what it is, it takes the loading guidance and the application out of Appendix C, which in this case, it's a 330 Newton load. But what it does, it also takes some additional guidance from Appendix H and makes it more relevant to glass behaviour. Appendix C is generally appropriate for barrier systems that do have some type of yield, whereas we know that glass barriers fail by catastrophic failure. So essentially what it is there is an SLS and ULS component to this. The SLS component is the 330 Newton load, and then we factor it up to be an ultimate load, and that's applied to the barrier. Now, importantly, this test methodology should not result in any significant change to common barrier configurations. Obviously, in the cases where there are a limited number of spigots, in the case of spigot-supported glass and the panels are very big, you probably won't pass, but in general, we should not see a move away from conventional toughened panels being used with appropriate support conditions. Only going to very briefly talk about performance solutions. It requires the use of an appropriately qualified person who can use an alternate pathway to demonstrate compliance. But as with all performance solutions, these must be the equivalent and no less stringent to the DTS requirements, but you can be used in a different way. And not much really to say on that. You were engaging an engineer to do that. I would just make them aware of the performance requirements relating to glass. So if they are doing a performance solution for a structural barrier with an interlinking, without an interlinking or load supporting handrail, that the loading should be done with one panel failed. And additionally, in terms of post-breakage performance, unless you model the interlayer on its own, it is impossible to model the failed condition of the glass. So in some cases, if you wanted to rely on a little bit of resistance from the broken glass, a performance solution may still require the use of a physical test to help demonstrate its performance. A question that is very common in relation to barriers is, what do we do when it comes to repairs and maintenance? Now, unfortunately, there is no black and white answer in relation to this. It is a very grey area, and unfortunately, some of our advice has to be quite limited on this. But essentially, it should be individually assessed based on risk. So you should be doing a risk assessment of some form to understand what is the risk with the potential work you're going to do in relation to the inherent safety of the system. Also, if you do encounter maintenance and repairs where the glass is, for instance, it's not safety glass, then there is a reasonable duty to inform the homeowner or whoever the engaging party is to say that this barrier is potentially very unsafe, specifically in regard to it not being safety glass. And with anything you do, it is very important to document your decision process so that you're able to demonstrate how you've made a decision. Just saying, oh, the old "she'll be right, mate" approach does not cut it. And to try and talk about this a little bit more, now this again is a very difficult area to talk about. I'll talk about the example on the right here. So in this case, you can see, so just to clarify, those heights are all above 1 metre on the right-hand photo, and the end panel has failed. There are at least 3 additional panels here, and the question, this was a tech inquiry post to AGWA, was what glass do I need to pick? Is like for like okay? Do I have to comply with the current standards? Now, as I mentioned, this is a very grey area. So the general advice that AGWA would provide is, where possible and appropriate, you should comply with the latest relevant standard, particularly if there's been a stringency increase. So if you are able to easily select and install glass into this scenario that does comply with the current provision 12 you would do so. In some instances, this may not be possible. For example, in an infill barrier, it may not have the channel width to support the thickness of glass that might be required. Then it would come down to an individual risk-based approach where, for instance, if I was replacing one panel, modifying that system substantially to put in glass that is compliant with the current version, considering this is an older barrier system, would I have changed the inherent safety of that system? And the answer may be probably not. But in the case of that same scenario, if you were replacing every panel in that balustrade application, then I would suggest that you probably are making a substantial difference to the inherent safety of the system, and it may be appropriate in that case to then upgrade the supports of the glass to carry the most compliant glass. If we look on the left, this is actually a video where a spontaneous failure was found of a glass panel. Now, in this case, I believe the next 2 panels were fractured from the one above. So again, this would be a different risk when you assess this. There has been some subsequent failures there. So potentially replacing it into, in this case, it's clearly above 5 metres, replacing it with a monolithic product would probably not be appropriate. But the main comment that I'd like to make here, there is no black and white answer. It is on a case-by-case basis, but where possible and appropriate, you should always try and comply with the latest standards. So, for example, in no case would you ever do a like-for-like if it was not a safety product, because it is more than reasonable to be able to do that. Where it becomes more complicated is with the thickness and type of glass. Now, I spent a fair bit of time talking about compliance pathways, and barriers are a difficult area, and we get posed the question all the time, this is too hard, why do we do this? There are very specific reasons for this, and it's a deferred risk element. So, there are people out there that are happy to put whatever in, go to their local hardware provider and buy some spigots or whatever they may be off the shelf and some toughened glass or other such glass and products and put it in and not worry about it. But what they are missing is the deferred risk element. So we'll talk about an example here. This is a photo. This is representative of a court case that AGWA was involved in. So this is not specific to what I'm about to discuss, but the barrier installation was the same. It was a mechanically fixed, toughened panel with no top rail. And in the case that we're involved in, 2 teenagers were wrestling on the balcony, and as they were wrestling, they impacted the barrier. Now the barrier failed, and they fell 4.5 metres, and both of them unfortunately were left with life-changing injuries. So, as part of the investigation and legal action that was commenced, AGWA was asked to provide comment on if the barrier system was compliant. So we utilised one of our members to assist us in this, and we did some work. Now, the barrier system was installed prior to the current provisions. It had been in for about 6 or 7 years. And as the standard was written at the time, that barrier system did comply with the relevant requirements. So in that case, it was lucky for the person who installed it. Now, they were not members of AGWA, but in that case, it was not something that was non-compliant. But if this had been a non-compliant installation and this injury happened, and as I said, this happened 6 years down the track, there could be significant personal and financial implications. So I would always encourage all our members, you should always do everything as best you can and comply, because saying that it'll be right may not always be the case. And in saying that, there is guidance that we can ask, saying, I've been told, for example, that if I use 12mm glass on standoffs and they're 200mm apart and I have a minimum of 4, I should be okay. I would suggest to you to never use general guidance, because there are a lot of unknown questions there. And if you do that and then there is an event and someone says to you, well, how do you know you're compliant? You wouldn't be able to rely on, well, Joe told me that it was okay, but you could not demonstrate compliance. Whereas if you did the design via Appendix H, for example, then you would have documentary evidence to say that the glass was adequately selected. So there are a number of Facebook forums that love to provide advice. I would also guard you on that, because you really need to be specific with the advice that you are given and make sure it's coming from a reliable source. Talk about what AGWA can help with. So we do have our technical help. Now, that's not related just to barrier systems, it's all glass and window related. It is quite a large component of what we do as an association, and one of 5 that provide a number of, at least we provide about 12 to 1300 technical responses per year. So when you have a question, even if it's just you're a little bit doubtful or you'd like some guidance, by all means, please reach out to us. We're here to help. Specifically for barriers, we're developing a number of fact sheets. Now, some of these have been quite delayed because this is a complex area. So we have a barrier selection guide that's just come out. We are doing some additional work on selecting glass using table 7.3, and we are very heavily working on guidance for Appendix H, just to clear up some interpretational issues. Now, this should have been out a long time ago, but it is quite a complex area. So I will apologise, this is taking much longer to get firmed up and published than we would have liked, but we are working on it. And also specifically, I will talk to one specific tool, which is what we're going to call ValueSafe. So this is essentially a barrier selection tool, and the idea of this is twofold. It's to allow members a little bit less, make it less complex to pick a compliant barrier system. So ValueSafe will essentially take hold of appropriate Appendix H test reports and then allow you to ask a number of questions to then potentially give you a number of Appendix H test reports that, comply with the specific installation that you're doing. Additionally for this, and there are some members on this call, I presented at the Queensland AIBS conference last week talking about this, but also the idea of ValueSafe is it's very easy for me to sit here and say, you must do all of this compliance work, and then the comment can be made, well, what about, which we refer to in industry, the man in a van or the cowboy down the street when he doesn't care about any of that? And that's relevant. So the idea of ValueSafe will be twofold. It should allow a easier pathway for installers to select compliant systems, but then it will generate a certificate of such, and then that can help certifiers, have a faith that the system has potentially been selected correctly. And when they don't see something like a ValueSafe certificate, well, then that should prompt them to ask a lot more questions regarding how that particular barrier system is demonstrating compliance. Again, this is quite a complex area. This tool is a little way off. I can't give any guidance on what it is. It is an active pathway we're working on, but this stuff will take some time, unfortunately. I'm going to move into the submitted questions. Now, looking at the timing we have a good bit of time up our sleeve. So after I go through the pre-submitted questions, we will open up the floor to a Q&A if anyone has any questions that hopefully I will be able to answer. In the case that I wouldn't be able to answer any question directed at me, I will take that on notice and I'll follow you up directly individually. Okay, the first one, are U-channel rails usually 15 by 15 by 1.6? Okay, almost certainly not. They generally will not survive the load requirement in the event that a panel fails, including an end panel. So these should be considered a non-load supporting handrail, and generally they're for decorative purposes only, or protection of laminates if required. Do all loads need to be applied for Appendix H tests? They certainly do. all of them must be applied regardless if they are a governing load. A little bit more complicated one. This is a common one that we've been seeing along. So essentially this is saying the barrier system is back from the live edge in a couple of meters, and they're saying, do we still need to comply if the height is greater than 5 meters? Do we still need to comply with the restriction of monolithic toughened glass? So in this case, this is an example. If we have a look at, we ignore that scaffolding there because this site's currently under remediation, you can see that that barrier is about a meter, maybe a meter and a bit away from the actual edge. And the question we're asked in various forms is, can I now use a monolithic product even if the actual height is above 5 meters? Now, the standard is somewhat silent on it, but it would be reasonable to say that no, you can't, because the definition is the barrier protecting a fall greater than 5 meters. So in the event that that barrier did fail, there is no subsequent protection after that. So that is the barrier providing protection from a fall greater than 5 meters. So it should be inferred that even though that there is some space in front, that a monolithic product would not be appropriate. Now, may that change in the future? It's a question I can't answer. If we relate it to heat soaking requirements, there is guidance given in terms of if it's suitably protected, but that guidance is not appropriate for barrier system, but it may be something that could be considered in the future, but there's no guarantee for that. It may be, as it's written, that if you are protecting a height of greater than 5 meters, you are restricted from a monolithic product. Two parts to this next one. So one question is, with so many imported balustrade units that don't comply and won't take thicker glass, is getting owners to get engineering cert the only option? It's an interesting question, this one, because if it is unable to comply, then you cannot get engineering certification because you would not be able to demonstrate it is at least as stringent as the DTS provision. So no, there is no option. If it is doesn't comply and you can't get the glass in that's required, you cannot use it as a barrier protecting a height. Second question, toughen is technically unsafe if it breaks as no second barrier. Laminate is only good in 4-inch support as it folds and falls out and susceptible to thermal breakage, leaving toughen laminate the only viable option. There's a little bit to unpack here. No, not necessarily. Conventional laminates, yes, they are not sufficiently rigid, but specifically there are higher performing rigid interlayers that are appropriate and more than safe. And in fact, if they are selected in accordance with 7.46, they are actually a little bit more stringent than what could be inferred with an interlinking handrail barrier, as the SLS load is done in a semi-failed fashion with one layer broken. So that is not entirely correct. The other one is it is not only leaving tough and laminate, heat strengthened laminate would be an appropriate glass selection as well. And some people may find that heat strengthened laminates may perform better in their post-breakage component than a toughened product, because obviously there is more glass intact, doesn't blow up to as many pieces, but there obviously will be some detrimental effects to serviceability in ULS loads. But so no, it's not only toughened laminate could be heat strengthened, but if it is in a support condition where there is no interlinking handrail or load supporting handrail, conventional laminates cannot be used. They must be a high performance laminate, simply because they have to resist the resulting post-breakage loads. Okay, I can appreciate some of the changes made here, but what I'm finding to have been forgotten is the fixing detail in the barrier itself. No good being 2452 triple laminate heat soak with solid hardware if the builder has left nothing more than a scrap of timber to fix to. An engineering design for the fixing absolutely required. This is an interesting question, so it's twofold. Fixing detail is important. It is not part of AS 1288 because it is outside the scope of AS 1288. And in the case of what the builder has left behind in terms of what he's provided to fix to, that's not necessarily an issue for the installer. You know, a good design should incorporate adequate fixing. In terms of would engineering be required? In some instances, fixing requirement will be required, but as an example, if the Appendix H report shows that the fixings were put into concrete and then you were intending to use it in an application that was a concrete decking or whatever it may be, or balcony, well then I would say no, you wouldn't need detailed engineering design for that. You would be able to use the guidance that's provided in 1170. Further to that, there are other areas that are being looked at to simplify this. In the case of using some guidance from the timber standards. But yes, this is an issue. Primarily the Appendix H and the guidance given within 1288 is for the barrier itself. and it's not within the scope to nominate fixings, but it still is an important consideration. Okay, the supplier has advised that frameless 12mm monolithic glass will not comply with the deflection requirements of 1288 when supported by spigots, and 15mm glass must be used. Is this correct? Two parts of this. First of all, depending on how they define what a frameless balustrade is, I would imply that that means it has no interlinking handrail, is you cannot use monolithic product because it doesn't satisfy the requirements. So let's assume when they mean frameless, they might be talking of something that has an interlinking handrail. In the case of only 15mm, no, I can speak to this very directly. I have seen Appendix H test reports where 12mm glass has satisfied the deflection criteria of 1288, which is a span on 30 or maximum 30mm. So I have seen results to this. Additionally, those results were without an interlinking handrail where the test was done. But in the case of if the testing was done as a system with the interlinking handrail, well, then would be reasonable that the interlinking handrail would provide some additional resistance. So I do not agree with that. There are a number of questions I would have with the supplier that has nominated that, but generally no, there's no generic guidance like that. As I said, I have seen 12mm monolithic pass on its own without the support of an interlinking handrail in testing. They are all the submitted questions. There is one in the chat I'll have a look at. In terms of engineered performance solutions in lieu of Appendix H, a generic engineered system is acceptable, or does each one need to be job specific? I've asked many suppliers for Appendix H. No one knows what I'm talking about. Generic design. Okay, I can answer this, I believe, but there may be some subtext here that we may need to reach out. There is a specific reason there is no generic guidance given for point fixings, as they differ. So the engagement of let's talk about spigot specifically, the engagement face of spigot to the glass